All right, let's take a look at the inverse normal CDF. So the symbol that's phi inverse represents the value of z with an area of phi of z to the left of it. So basically, if you have this normal curve and there's an area of phi of z here, this pink area, the z-score, that is the boundary between phi of z and the area to the right, is the inverse of phi. You can give the inverse of phi that area, phi of z, and it'll give you the value of z. So we're going to use Python to do this. In Python, if you're looking for the inverse standard normal CDF, then you're going to import scipy.stats as stats. And then you're going to use stats.norm, but instead of the CDF, this time we're using the PPF, and you're going to feed it the area, that CDF function. So whatever that area is, the CDF, you're going to feed it to the PPF, and the PPF is going to give you the z-score. Now, on the other hand, if it's not a standard normal, but it has a different mean than 0 or a different standard deviation or variance than 1, then you can still use the inverse normal CDF, but you're going to have to plug in these other two parameters. The PPF, I mean, not the CDF. Then you can still use the inverse normal CDF, but when you use the inverse normal CDF in this situation, not only are you putting in the area, which is phi of z, but you're also plugging in the mean and the standard deviation in that order. So let's try it out. Here I see that they give me that the phi of z, or the area to the left of a specific z-score, is 0.111. They want me to find the z-score. So they want me to find the z-score is somewhere between -1 and -2. Let's go ahead and find it. To find it, I'm going to use Python. And here we have a Python window. All right. So I'm going to use the function that's given here. And since it's a standard normal distribution, I don't need this one. I'm going to use this one. All I'm going to need to feed to this is the area. So I'm going to import the relevant dependencies or libraries here. It's going to be import scipy.stats, and we're going to import that as stats. So we imported scipy.stats as stats, and then after we do that, we can now call the stats.norm.ppf, which is the inverse normal. So stats.norm.ppf, and what I'm going to plug into that is the area that they gave me. So the area that they gave me is, they told me that that area to the left is 0.111. So I'm just plugging into this thing 0.111. Now when I run this code, it's going to give me the z-score. So I fed it the area. It gave me the z-score that has that area to the left. So the z-score it's looking for here is -1.2. What was that? 2. -1.22. And I put a 0 in. -1.22. So -1.22 is it there. Okay, so for this problem, they want me to find the z-score that separates an area of 0.043 to the right. The problem with that is that the PPF, the norm PPF function in Python, only takes the area to the left. So if you're given the area to the right, you're going to have to find the complement. And that's what we're going to do. So since they're giving me this blue area and the PPF only takes the area to the left, which would be this white area, all I have to do is take that blue area and subtract it from 1. So that's what I'm going to do in Python here. So I've already imported scipy as stats. So I'm just going to add a code cell here and repeat this, except I'm not going to take the number. I'm just going to take everything up to and after the parenthesis here. And I'm going to paste it here. All right, so the number I'm looking for is not that number, because I can only plug into this thing the area to the left. So I'm plugging in 1 minus that number, 0.043 because that's the area to the left. That 1 minus that complement will be the area to the left. When I run this, it tells me that that z-score that separates that area, that blue area and the white area, is 1.72 if rounded to 2 decimal places. And that's what they want us to do. So this is 1.72.